Welcome to Elixir Wizards, a podcast brought to you by SmartLogic, a custom web and mobile development shop. This is Season 15, The State of the Stack. Join us for conversations about how the software development landscape is evolving.
Each episode examines observable shifts, what's driving those changes, and how people in the community are adapting in response.
Hi, everyone. I'm Charles Suggs, software developer at SmartLogic.
And I'm Emma Whamond, also a software developer at SmartLogic. And we're your hosts for Season 15, Episode 8. We're joined by Mike Ratliff, co-founder and CTO of GridVar. Mike has spent over 30 years building software, leading engineering organizations, and has focused much of his career on utilities, distributed energy systems, and electricity. In a season focused on how technology is adapting to a changing landscape, we're looking at one of the largest and most complex systems, the power grid.
Hey, Mike. Welcome to the podcast.
Hey, thanks for having me on. It's great to be here.
Yeah, nice to have you. You've had a pretty fascinating career so far. Maybe you can give us some of the cliff notes of that journey and how you got into the energy and utility space and what you're doing today.
Yeah, it has been kind of a winding path. I think, the front half of my career was all about kind of exploration around the software domain, and spent a lot of time working in different product and consulting companies, kind of getting a feel for what was out there. And then when I got an opportunity to work in the energy space, it really wasn't my plan initially to get into that. But as soon as I started working on some problems in that space in kind of a small area, I kind of realized that it was one of those industries that was ripe for a lot of change. And it's probably like what the banking industry went through and telecom industry went through in years before. There were just going to be a lot of things that were going to need to be thought about and worked on. And so it just became a little bit of a passion. And then as I wrapped up each project or each company, it just kind of naturally started to roll into other opportunities there because new challenges were coming about on the grid all the time. And, it seemed like a never-ending faucet of just opportunities to look at these kind of like world-changing problems. We all use power as a species in really different ways, and things are changing pretty dramatically over the last decade or two.
Kind of fits with our theme of the state of the stack and how everything is, a lot is changing.
It is.
Yeah. I suppose some would say good and some would say bad or both.
Yeah, I don't think anything's ever, 100% one way or the other on that front. So you'd have to tease it apart there and take the good with the bad.
Definitely. Yeah. And you've worked through several waves of change in our industry, from some of the early internet era to cloud computing and AI now. What shifts have felt most significant to you?
Yeah, it's a really easy question to go right to, like what's happening today, because everything seems so dramatic and all the changes that we're going through. But I do think that there's been some interesting parallels in all of those phases, and it's probably become a little bit more in focus right now. But I think one of the things that has been interesting to me to watch over those changes is that one of the consistencies is taste and insight about what's going on and how to apply that to what's really happening in our industry. And that really hasn't changed a lot. It maybe has had a little bit more of a magnifying glass put on it in what we can all do today and the breadth that we can apply that taste. But, I think that has been one of the interesting kind of consistent pieces that each one of those phases has gone through. Is you've seen a lot of people spend a lot of time and effort building things that ended up not really mattering in the end. And some of that you could probably look back with the benefit of hindsight and say, yeah, if we'd thought a little bit harder about this and really applied some thinkings about what's going on in other industries and what's happened, you may have been able to avoid some of those things. And I think that's just such a timely lesson for what we're experiencing now, because it's so easy to build things that really it's coming down to having that insight to say, should this be built? And if it should it be built in this particular way? And so people that are going to figure that out, I think are going to have a lot of fun in this next round of changes.
Do you think some of that is about deferring engineering decisions until it's something you need to be focused on? Or is it also about really kind of thinking through a lot of those possibilities to know what makes sense to defer or to not build yet?
Yeah, that's a really interesting way of putting it. And I guess the the knee-jerk reaction that I have to that is that maybe we don't have to defer quite as many things as maybe we should have a few years ago, because what we can actually explore at a very, very high fidelity is fairly astounding now. And so, what I've found in this startup that I've been working on is that we don't really tend to defer a lot of hard engineering problems. We kind of tackle them head on. And even if we have to end up throwing away something, it's not a very large investment in terms of time and effort in order to do that. And you just have to have the willingness to be able to let go and be like, yeah, that was a great learning experience, but it's wrong. So let's just nuke it all.
Ease of building is one thing. What else how would you compare the industry today to when you started in the 90s? Like, what feels fundamentally different?
Yeah, I think the breadth at which we can have influence is just completely different. It was in vogue back in, the 90s and maybe the 2000s to have, fairly specific titles, database engineer, front-end engineer and whatnot. And that just seems kind of prosaic now, because all the people that I work with that are really having the most fun and seem to be having the most impact are kind of the generalists. And that's, I think that's been an interesting thing for me to kind of come to terms with, because I think for most of my career, I was a generalist. I experimented with a lot of different things, and I was never the best at any one thing. And I was always kind of looking back going, God, am I making the right decisions? Should I have gone really deep into one particular thing and become that expert? And then today happened with all of the tooling that we have at our fingertips. And I'm so grateful that I was kind of just exploratory and kind of creative with my choices, because it's that ability to kind of connect these weird, seemingly unrelated dots that I think is a lot of fun today, and where people are becoming really, really powerful in being able to do to pull those things in. And those are the folks you really want to work with today, are the ones that can make these connections that you're like, wow, where did you come up with that? And it's because they did some random thing 10 years ago in their life that they remembered, and then it all comes together. And that's been super cool to watch happen, and watch other folks kind of have that aha moment that something they thought was a throwaway idea now becomes core to something that made a business decision actually work.
I love that answer. It certainly is the age of the generalist and the people that are willing to be generalists, right?
Yeah, absolutely.
Are there any aspects of the industry today versus the 90s that feel surprisingly unchanged?
Mm-hmm. Taste still matters. I mean, I kind of keep coming back to that, but it's, I think we have a very significant shortage of people with really good taste and insight. And that's no different today as it was before. I think it maybe even gets magnified a little bit more today, just because people can deliver things much more quickly. So it's very much in your face if somebody's built something that isn't quite there. But yeah, I would like to think that has been kind of the unifying human thread throughout all this, that we're just getting a little bit better at all the time. That's my hope anyway.
When you build the wrong thing with real world infrastructure, it's even more kind of in your face and maybe lasts longer too, given the physical nature of some of that.
Yeah, it's been several of the projects that I've worked on have had aspects where they go out and they touch physical devices, whether that's the entire grid itself, or it's just physical devices within buildings and things like that. And that's a very fascinating way to build, or aspect of building tools, because the hardware world and the software world don't exactly line up in the way that you go about building things. And I'm not a hardware engineer by trade, so I don't want to claim my experience is spectacular here. But I've had to learn how to lead hardware engineering teams, and as a result, I've learned a little bit. And as a result of being with very talented people on that side of the world, and that bringing together of those two different cadences and two different levels of kind of how rigor gets achieved has been really fascinating to watch because, you get a lot of chances to make things right in software. And so you end up getting this little bit of a cavalier attitude sometimes, where with hardware, you get a couple of chances to get it right. And once you've got 10,000, 100,000 of these devices out in the world, if something's really wrong, it bankrupts your company. And that is, it requires a different level of thought and careful rigor up front that we've kind of eschewed in the software world. And we use a lot of other techniques to kind of get by on that front. And when you try to bring those two worlds together, it is an interesting cultural mishmash, to say the least.
Digging more into kind of the utility and energy space where you've spent a bit of your career and particularly more recent, what makes building software for utilities and these energy systems different from building software for a SaaS application or something that, you just deploy to a server, and if it doesn't work, you can deploy again and again?
Yeah. I think utilities they're by nature one of the more risk-adverse cultures that you will interact with out there. And, that makes it very hard to engage with them, especially as a small startup and things like that, because they have to bet on these very long-term business plans. And so the one thing that I've found that has been helpful in kind of getting software to get that kind of flywheel nature of getting engaged with is you can never really think about trying to sell software to a utility that is actually going to alter something on the grid right up front. Because they're going to want to go through this phase where they understand, like you kind of go through this like data collection, analysis, prediction, and then control level of evolution. And if you can find a company and a business problem that has some beats on each one of those, that has value that you can deliver, then you can kind of escalate up to that level of actual control. And that's really hard to do. And it's a long journey and process. But I think is the current opportunity that I'm working on, we're really going through that today of like, how do we add value without running into some of those really real valid roadblocks that utilities are going to put up to keep the grid stable. They need that, and they need to be skeptical.
So what kind of work are you doing with GridVar that you think would kind of enable you to work your way into that flow of change that utilities work with?
So what we're trying to do, and everybody's probably heard this, like there's this problem today where connecting large loads to the grid is a huge problem. And it's a problem for a couple different reasons. One, there just isn't the power available. And so if you need a gigawatt for a data center, finding a gigawatt of real power is a challenge, but kind of the answer to that problem is really relatively easy. It's like, is there a gigawatt or not? That's not the real problem with interconnection, although that's what you hear about, like the lack of power. Where these developers are really struggling a lot of times is they may find the power or they may procure the power themselves, and then they go to actually interconnect and they get deep in that cycle. They've committed a ton of capital. And then they find out that the power quality problems that they're going to induce on the grid have kicked them out of the queue. So they have voltage excursions, they have harmonic problems, they have all these other things. And so that's the problem that we're trying to really attack and basically build software that can simulate all of those problems from a power quality perspective that you would normally have to pay, hundreds of thousands of dollars and wait months to get those studies done. We've built software that allows a non-technical user to get those answers in minutes. And so they can sit there and experiment with a lot of different approaches and then, find a good connection strategy so that they know exactly what they're getting into. And so from that perspective, that is that kind of collection and analysis and prediction step where we're not actually doing the control side of the grid yet. We're doing the on-ramping side. And so your risk tolerance is in a completely different place.
In Illinois, we've had a lot of legislation to promote expansion of solar and such, and among other things. But one of the hurdles we keep hearing about is getting grid interconnection approved by either the utility or the grid operators. And it sounds like what you're working on might alleviate some of that if it's especially due to like power quality problems.
Yeah. And I think, it is an area that a lot of people are looking at. And as I've been working on this particular company for about 9 months, and we're not the only ones. Like there's a bunch of people looking at this problem because there's a ton of money, being locked up by this. And so that gives me a lot of hope that a lot of smart people are looking at these problems and trying to find some good solutions, because it's broken in such ways that it boggles the mind at the scale of backlog that is out there. It's astounding.
So I heard that you said utilities are slow to adopt a new technology.
Yeah,
It's not entirely irrational.
it's not.
When a SaaS company has an outage, people complain on X, and when a utility has an outage, people die in extreme weather or traffic lights fail. Hospitals have to run on backup power. In the technology space, there's a parallel there between moving software towards distributed systems, and then the grids move towards a distributed energy. So when we talk about distributed energy, could you give us a rundown of what you mean by that?
Yeah, I mean, I think the best way that I understand it is to think of it that for decades, the grid has operated really well by this centralized control mechanism. And where we say generation chases load. And what that means is that if everybody consuming power starts consuming more power, all the generation ramps up to service that. And this model has treated us very, very well for many, many decades. But the reality is it's starting to fail, and utilities are seeing that. And it's failing because the level of dynamism of the loads is so dramatic that it's hard to chase those loads fast enough. And it's also a challenge that the cost to actually deliver power at any moment, at any level, is astronomical. I mean, so we have this huge amount of waste of overbuilt capacity so that we can ensure the grid stability. And, this is all shifting. And so when we think about distributed energy, a lot of things I think about are how do we invert that control? And that inversion comes on a couple different axes. One of them is that load should follow generation instead of the other way around. And that really means a lot of times having cost signals or price signals that change people's behavior so that they consume power in a more responsible way. And it also means that we are generating and consuming and storing power out at the edge of the grid instead of at the centralized part of it. And that means that the classic model of centralized control just really can't play anymore. If you go into a utilities, operating center, a lot of times you'll see there's an enormous amount of information on there, but there's still humans in the loop making decisions. And that's great when things change by minutes and hours, but it completely fails when things change in sub-second cycles. And that's the reality that we're going into today, that the machines are going to have to control large aspects of this. And that's terrifying to an organization that has traditionally not turned over that level of automation.
What does that look like? Is that like devices at the end users that are doing some kind of demand side response that maybe moderates some of their load at peak times for the grid, or when it's advantageous to dial something back, or maybe to ramp something up because there's too much on the grid and they need to vent off some power? Go ahead.
No, yeah, you actually, I like the fact that you went both directions with that, because a lot of times people just think about ramping down consumption, but we're in a world where sometimes we have an overabundance of power, especially where there's a heavy influence of wind and solar. There's this thing called a duck curve that we talk about in the power industry, where it's the way the power signal looks when you have a lot of solar, in the afternoon that drops off as soon as the evening starts to come on, and all of the air conditioners and people come home start to come in, and that mismatch has been a real challenge. And so, yes, it is really about having devices that can respond to the realities of what's going on in real time and not have a human have to deal with that. And if you do that in each individual place and you have some relatively reasonable guidelines, and it's a very complicated system, but when you break it down, it's very simple at the individual nodes. There's like, hey, behave well here. And, if everybody behaves within those realms, things can start to self-heal a little bit more. But that world is very slow to come about. People don't want to give up their control. Utilities don't want to give up their control. And so we're kind of stuck in this very rigid case where people see the solutions that need to be out there, but don't always follow through with making them real.
The elixirist in me picks up on self-healing here as you talk about the grid. Are there lessons that software developers can take from, say, the world of distributed energy and apply that to distributed computing?
It's weird. I would almost invert that and say that maybe the world of software developers, especially even the Elixir world, has got a lot of this figured out, and that needs to flow into the energy side of things, because we have been holding very tightly onto this centralized control metaphor for so long in there. And so I think it actually flows that direction right now. I'm not sure there are a lot of lessons that we can pull from the grid itself right now in terms of distributed control and things like that. I think that's the weakness in the grid today.
So with rooftop solar, home batteries, EV chargers, microgrids, virtual power plants, all the are those other aspects of the distributed energy system that go into all of this instead of just being taken, also giving energy? Kind of goes back to the distributed system of software.
Yeah, I mean, microgrids are a great tool, and you're probably going to see more and more of those come about because, you can kind of abstract a lot of nuanced behavior behind this point of interconnection. And if you get an agreement with the utility to say, like, we're going to make this point of interconnection behave within these parameters, and that just creates a simplicity in a moment in a large, complicated network. And, I think that is something that you're seeing a lot. A lot of the hyperscale data centers and stuff that we're starting to model for interconnection. One of the big problems is like the level of swing that they create on the grid in terms of voltage and harmonics and things like that. And if you can come to the utility and say, yes, what's going on behind our meter or our point of interconnection is all over the board, but we're going to put in the gear to make it look really stable at the point of interconnection. The utility is like, thank you. I have one less thing to worry about. And I think that like tool right there to think about these islands and these moments of stability that everybody's driving towards, that's going to be what starts to unclog some of this backlog of the interconnection. Because when I talk to power systems engineers, that's what they're most terrified of, is plugging in these hyperscale data centers, and they just don't know. They don't have the math to really describe what's going to happen in a sub-cycle moment when, those GPUs dump all their memory and they go from a gigawatt to 100 megawatts of power in no time at all, and what occurs there. And you see it even in smaller cases, like, if you plug your EV into your house and things are a little like, you can actually hear and see the harmonics sometimes in the lights and things like that. That's real. I mean, we see that, and it's not even localized. We see data centers providing hitting those harmonics that are being measured hundreds of miles away.
Wow.
It's amazing.
We're all connected.
We are. And I'm honestly astounded every time I flip a light switch and the power comes on. Like that's how terrifyingly fragile I think things are getting.
That brings an interesting question about cybersecurity on the grid. This is something that's been in the news, of course, for a while now. Does distribution make that situation better? Does it make it worse or more complicated? And what role does software have to play in that?
Yeah, I mean, so I'm not a cybersecurity expert, but I think that anytime you talk about these pendulum swings from centralized to distributed, that it's not about it being better or worse. It's about trading one set of problems for another set of problems. And you may like some of the problems on one side of the pendulum swing better. And I think what's nice about the move that we're going through now is that any individual problem is becoming less and less impactful. Because if you do have a microgrid, for example, that has, one point of interconnection and you've managed that, even if something, goes on, you get one individual thing gets hacked inside of there, odds are the control systems for the other devices and stuff will be able to make up for that in some way. And so I think that's better. But man, the attack surface has gotten really, really large. And that's, I think, what has gotten most people frightened on that front. And so, I just think in general that attack surface problem is really interesting right now because you see what's going on with the AI models being able to find vulnerabilities. So I think we're going through this 6 to 18 month time period where things are just terrifying. But then we will probably harden a lot of our just tragic mistakes that we've made over the last few decades and maybe get out the back end of something where our systems are more resilient at that point. But the next 18 months is going to be an interesting ride.
So I'd like to look a little bit further in the future with climate events, placing and increasing stress on the infrastructure system. How are utilities adapting to a world that might be less predictable than it was 20 or 30 years ago?
So even though I've been in this space for 16 odd years, I've never actually worked at a utility. I've sold to utilities and I've got friends that work there. And so, I think my answer is going to be a little bit of an arm's length distance from that. But I do think that the paranoia and the cautiousness is both working for and against the utilities on that front. I like the fact that there's a lot of thought being placed into how does the system actually respond underneath all of these different contingencies that they simulate. And utilities do a great job of simulating a massive number of contingencies. And so that's something you can kind of take a little bit of comfort in. But the ability to simulate every possible failure is just not real. And I think if we could put one thing in place that would maybe start to help that, and we're starting to see it, is just decoupling the generation and load link that has always had to be completely in sync. And, that's where large-scale storage is really going to come to the rescue of being able to kind of create a buffer in how all this stuff operates. It's not there yet from a cost perspective, but as you start to see more and more of that come online, I think you're going to have the ability to absorb more and more of these changes in a reasonable way. And that is probably we need that shock absorber in the power grid. And if I were to bet on one thing, it would be wide-scale storage deployment that would get us to that a little bit more of a safety margin there.
I've read that when industrial scale solar facilities are having trouble with grid interconnection, or they have some, but they are not able to get another facility online, well, if they add battery storage at an existing facility and add more panels there, now they've flattened their load curve where it's no longer peaking when it's sunny and dropping at night, but they can, with the battery storage, just smooth it out.
That's exactly it. You nailed it. The storage combining with renewables is really the key, because it has been as much as I lean very left in my politics and thinking, I'm a realist about where we are today and the base load and the peaking load generation. There's a lot of natural gas that we burn, but it's necessary in order to keep things balanced out until we can get exactly what you said to be ubiquitous. And at that point, we can really start to see renewables become a much more reasonable player in terms of long-term 24/7 energy storage. It's really hard. I mean, we built software here at GridVar that can simulate building microgrids, and I've gone through and built thousands and thousands of different microgrids with this. And what's disheartening is that it's really hard to build something that can operate 24/7 without burning natural gas.
So it's our understanding that as CTO at GridPoint, you played a role in bringing Elixir to the company. Could you give us a rundown of some characteristics of Elixir that made it a good fit for energy and utility applications? I know you've talked about distributed energy, but anything else you could speak to?
Yeah, I brought Elixir into now like 5 or 6 different companies. It's kind of been my go-to tool set for a lot of these projects. And, I think for me, a lot of it came down to the peace of mind of being able to go to sleep and knowing that there's a layer of protection around, like, if you do it right, that, even if you have defects, that things are not going to completely go sideways, and that, you can get a lot more self-recovery. I think that's been really hugely beneficial. And I think the other thing is that just the nature of how it seems that the Beam does a really, really good job of maybe not being really fast, but never falling over, even in the midst of like added stress or more data flowing in and things like that. And that has been really important to me because, I build systems that run 24/7. You don't like get a break. And so having something that has that ability to have some back pressure and some recovery around the processing when you're just getting a fire hose of telemetry coming in all the time has been really a great piece. And then, it's hard to ignore just the productivity that you get around the ecosystem as well. I try to keep up with what's going on in the tech world and try to keep an open mind with other frameworks and things like that. And I got to be honest, like I still haven't found anything that solves these problems as well. So open-minded about it, but I haven't seen anything out there.
Happy to hear that because we agree.
Yeah.
Lightweight processes, supervision trees, fault tolerance. Yeah.
There's a lot of places, there's a lot of stacks that seem to be trying to pull some of the superficial benefits of the Beam. And it's really kind of disheartening to read about that. And you're like, well, like you took the names, but you don't really have the real piece behind it. And I don't know if everybody reading that truly appreciates how different some of the implementations of some of those features are when they try to pull them into another runtime.
We interviewed someone last week that was teaching others how to bring Elixir into new companies. So it's the perfect segue. Were there any challenges unique to Elixir in applying it to an energy or utility space?
Yeah, I mean, it wasn't too bad. I'm fortunate in that, I've been able for a long time, I've done CTO level roles. And so you get a lot of latitude in being able to make these decisions. And so you don't have to manage up quite as much bringing the technology in. But I will say, like, when a utility goes through due diligence on your platform, you hope that it's primarily about penetration tests and things like that and deployment architecture and all that. And that is a big part of it. But there's always a question about, like, what's this made in? And for me, it really, I'm upfront about it. It's like, hey, we built this in Elixir and here's why. I just immediately go into, like, we know that you need this to run 24/7. You need it to have this level of resilience. Here are the things that this framework gives you. And and there's some good references out there now that you can point people to that are at least semi-technical to be able to understand. And honestly, it really hasn't been a sticking point. I think the biggest sticking points that I've had in adopting Elixir is when I've come into companies before that were maybe kind of down the road and they brought me in to like maybe fix things. And, I've begrudgingly done a couple of pretty significant replatforming to Elixir. I say begrudgingly because that's always a terrifying and annoying thing to have to do, but sometimes it's necessary. And those are the hard ones. It's not so much about a hard discussion about why Elixir. It's more of a hard discussion about why are we going to spend all that money, and can you prove to me that this is really going to be a better way of doing things? And that's the hard equation, but that's not an Elixir specific discussion.
What what tends to kind of get people to buy in who are skeptical about doing a replatforming?
Yeah. I mean, it's all about money. And it all has to come down to that. And you have to be able to paint a picture of from every angle. Okay, here are what the customers are saying. Here are the frustrations they're experiencing. Here's what sales is unable to do. Here's where marketing has to paint a really interesting story. Here's where, and you just go across that, and a company knows where those pain points are. But when you pull them all together and you create a cohesive narrative around why all of the woes that a company is experiencing are all pointing back to, a platform or a tool or whatever that is causing this friction, then you can stand a chance. And I'm a big believer in storytelling, and as a way of changing people's minds. Facts and figures will never do it. If you don't have your facts, somebody can say no, but they'll never say yes based on facts. The facts just keep you from saying no. It's the story that you tell around that will get people to either believe or not believe in a certain path and journey. And that works for both replatforming things like this, or just, trying to go down and open up a business line or anything like that. You can take it small or large. If you can tell a good story, you're going to be able to spread your influence so much more widely than otherwise. And I think people shortchange that a lot. For a lot of my career, I was like, hey, if you just had the right data, surely people will come along. And you wonder why they don't. And it's like, well, we were like created as a species of sitting around fires, sharing knowledge through stories, and that hasn't changed. And that's where people actually decide to do something or to come along for a journey. And so if I were to go back to my early self, I would have said that learn to tell stories earlier. That would have been some of the best career advice I could have given myself.
To quote Sasha Juric, who I think we just published his episode this morning, telling a story with your commits and your pull request all the way through to talking with product owners and managers and decision makers.
That's so true. I love that.
Speaking of past and stories, we didn't really get into this earlier, but what's your Elixir story? How did you come to the language and the beam? And
that's so interesting. I built the first energy company I worked with. We built a platform for demand response in Ruby and Rails, and it was awesome from a delivery perspective. We were able to build something really quickly and whatnot. But it was a two-way connected system with all these thermostats and things that were sending telemetry back in real time, and it started as we became more and more successful. It was becoming a real problem, and we were at least struggling to get the scale to work out when you have these persistent connections, always open. It wasn't like where you have a user logging on and logging off. It was just a very different model. And one of the engineers on the team, I can't take any credit for this, at that time had put an MQTT server in between those that was written in Erlang. And I didn't actually at the time appreciate what that actually meant. It took me several years to truly kind of unwind what was really going on there. But and then I heard about the very kind of beginnings of the Elixir story starting to unfold, and it just seemed like a really the solution that I needed to solve these types of scaling and resiliency problems of the types of apps that I was building. And so it was really early on, pre 1.0 Phoenix days, and we started using it at one of the companies to build a virtual power plant application. And it was still rough back then. It was probably with the benefit of hindsight, it was probably a little early to jump on the Elixir bandwagon to do it, but we actually ended up, being relatively successful. That company sold to an acquirer and whatnot. And I even see the acquirer actually was a sponsor at one of the Elixir comps for a few years. So yeah, that was kind of the path. And, I've just kind of ridden it since then and watched it mature. And now it's almost become a default decision.
So bring it back to the future now. but kind of staying with software a little bit, what does the future of software really kind of look like in the energy sector? And maybe as a second question, if you could also tell our audience a little bit about what a virtual power plant is. I think that might not be familiar to everyone here.
Yeah. Sorry to use language that's industry specific. And so when you talk about a virtual power plant, different people have different definitions, but I think at its core, you're trying to aggregate devices together and to look at how the sum of those devices can be treated as one unified unit. And whether they're in one location or even distributed across many locations, you're kind of casting an envelope over those and saying, these things are going to operate in an orchestration and give you a unified result. And it could be load and generation and storage, all mixed together. It could be what we call non-wires alternatives, where it's like the behavior of something changes. And so all of these things get stitched together, and you've essentially created a facade around that you can like go to a utility or somebody and say, hey, we've got, a gigawatt and a half of dynamic capacity in your territory. Would you like to purchase that? Or would you like to use that for some resiliency event or something like that? And so that's kind of the deal behind a virtual power plant. The other question was, what's software going to look like in the utility space? Was that what it was?
Or energy sector, which I suppose might be a little more broad than just utilities.
Yeah. I'm a big believer that our world, I think somebody else said this. This wasn't like my observation, so I'm going to steal it. And I can't remember who to give credit for. But I think the world of software, like solutions, is going to saturate pretty quickly. Like the ability to solve software-only problems is going to get easier and easier and faster and faster. And it's not like those jobs are going to go away or anything like that. I'm not a proponent of that level of thought. I just think it's going to be very easy to build things. When you combine hardware and software or software with the real world and like going out and physically touching something or changing physical behavior, I think that's another frontier out there. And I think the really impactful software projects are going to have, a lot of those are going to have a component of that, of like, how do they reach out and touch the world? And I think that's kind of exciting. Most of the software engineers that I've worked with that have gotten a taste of controlling something in the real world have absolutely loved it. I mean, it's frustrating to no end when something doesn't work and whatnot, but it is also very, very rewarding when it actually plays out. And so I think you're going to see more and more melding of that. And hopefully those lines between those two disciplines will continue to start to blur a little bit more. I would love to do more and more of those projects.
We're starting to see a lot of that blurring even now. We've become increasingly dependent on electricity over the past few decades. AI, data centers, electric vehicles, remote work, commerce, moving online. Are we entering a fundamentally different era of energy demands? And how is AI playing a role in that? What are you saying on your side?
Well, I mean, from a demand perspective, the backlogs of how much power people would like to have access to is almost dwarfing how much power we have access to. Like that's like to put the order of magnitude on the table there. You cannot buy gas turbines. They're like 5 years out. You cannot buy, like you've got people that are building bespoke transmission lines outside of the utilities foray and like doing it on spec. Like people realize how it's just not like a step change. It's like a logarithmic scale change in how much power our world is hungry to consume right now. And so, in all this, it clearly was driven, most of it by these AI data centers, and that's not going to stop. Even with the efficiencies and inference that we see, coming, that's going to get dwarfed by the usage of what's going on. And so I don't think that most people have an idea of the orders of magnitude of power that really need to be acquired. And so it's not any one solution here. It is yes and to all of the forms of power acquisition and transmission. And that's one of the biggest problems I think that we have here, especially in the States, is transmission. And why I say that is that a lot of the renewable sources are not easily located where we need power. And we do not have enough transmission in place to move those renewable sources around our country. And if we hope to get to a place where we are more and more reliant on renewables, we're going to have to figure out a way to build things again and not get bogged down in years and years of permitting red tape that has cost us a lot, I think.
I completely agree. It's a conversation I've had often here in my household. My boyfriend works in nuclear, and is a scientist in nuclear, and this has been a huge issue. He was working in Europe for a while, and yeah, the energy consumption in general, just it's larger than people realize.
Yeah, I hope we can get back to realizing that there are safe ways to use nuclear, because some of the new designs of those plants are super promising, and that is a fantastic way to get relatively cheap and clean and safe power if it's done right.
Absolutely. So what have you been seeing at GridVar about the feasibility of introducing these data centers into the grid? Just give a quick rundown. Sorry if it's a big question.
No, it is. It's a good one. I love it. I mean, it's like, that's what we're trying to figure out every day. So obviously, like I said before, we're working on the power quality side of this problem. There's a whole real power acquisition side. It's really not our foray and is a huge problem. But we think our thesis of why we should exist as a company is that there is this power quality issue, and it's only getting worse. And it's getting worse because of the level of dynamism of these loads. And people just there just aren't good models to understand how this is going to affect the wider grid. And, this may not have been a big news story here in the States, but it wasn't too long ago where there was a huge, massive blackout in Spain. And when you start to dig into that, it is the dynamics of these, of things that are happening much more rapidly than they ever did, that is becoming a more and more regular occurrence. Whether it's data centers as the pure source or other types of things as the source of that, it is just dynamism in general that is causing these new problems. And so, I'm hopeful that, these things can be designed in ways that have things that are going like this and turn them into things that go like this. Stable instead of chaotic. And that if you treat every interconnection point as like it has to have a rigor around its operating envelope, I think we stand a chance of evolving our grid. But if we let things just behave the way they want to behave, and impact outside of the point of interconnection, I'm frightened, and I'm glad I have my own power generation source here in my home in Maine. Because it'll get weird if we don't figure that out.
For engineers early in their careers, what lessons have kind of remained true throughout your 30 plus years in software?
I think if you want to be in this industry, you've got to love being able to learn every single day. And like that has to be just that level of curiosity. And it's not necessarily learning technology. That's an important piece. But, pick up those other things, go study some other area, but then learn a domain. I think if there's one thing that I can tell people, it's that we're no longer living in a world, I think, where you can effectively be just a software engineer and be like, hey, tell me what I should build. Those days are over. If I'm going to be hiring software engineers, I want them to understand intimately what this domain is all about and be able to make real-time decisions. Because I think what's been fascinating for me, listening to all this rhetoric around people on one side of the AI argument that say, my God, it's 100x improvement in speed, and people on the other side to say, I see no speed improvement at all. And I try to reconcile that, because I know people on both sides of this. I know they're smart. I believe their experience. And the only thing that I can come down to is that it's this time to pause issue. And what I mean by that is if you're getting an AI to write a bunch of code really quickly, but then you come to a moment where a decision has to be made and you're still working under the assumption where you've got to go talk to somebody like another group or you got to figure something out, then it doesn't matter that you got to write the code 10 times faster. It's all erased in the process of going back and forth to try to figure out how to move forward. And if you're somebody that really understands a domain, you can make that instant decision in that moment and keep moving. And that's what I've seen over the last 9 months as I've been building GridVar, is like, it's not a 5 or a 10x improvement. It's like 100x improvement in throughput. But that's only because there's never a pause. Like when something goes wrong or like there's a question, I can answer it and I can get it back online. And that's where all the speed is coming from, not the fact that the models can actually build code fast. That's nice, but that's a rounding error in terms of all of the error that you take out of the system by being able to make these judgment calls. And so figure out a way if you're a junior engineer, figure out a way to become that person that can make those judgment calls real time and get them right 80% of the time. And you're going to be hugely valuable.
I love that. It's so relatable to every aspect of someone's life outside of just a career advice. As we get to time and start wrapping up, where can listeners learn more about your work, GridVar, or how to get involved in the energy space?
Yeah, you can check out our website at gridvar.com. You can reach out to me at mike@gridvar.com, and I'm happy to respond there. Yeah, and if people want to get involved, we're definitely going to be, looking for Elixir engineers that have a passion and a knowledge around the energy space. And so happy to talk to folks that are excited about that.
Thank you so much, Mike.
Well, thank you. That's been awesome. I appreciate it.
Yeah, it's a really interesting conversation, and I really enjoyed it.
Yeah, thanks for all the great questions. I really appreciate it.
Yeah, thank you. I've also enjoyed this conversation, and I look forward to hearing more about how this space evolves. And for our listeners who are not as familiar with a lot of the energy space stuff we've been talking about, while we're an Elixir-focused podcast, and that's largely where we're going to stay, there are a lot of other opportunities out there to learn more about this stuff. The Volts podcast and some others exist that are worth listening to as well. Our guest has been Mike Ratliff from GridVar, and it's been a pleasure to speaking with you. Elixir Wizards is a production of Smart Logic. You can find us online at smartlogic.io.
Don't forget to like, subscribe, and leave a review. This episode was produced and edited by Paloma Pachenik for Smart Logic.
Thanks for joining us, and we'll see you next week for another episode of The State of the Stack.
Hey, this is Yair Flicker, president of Smart Logic, the company that brings you this podcast. Smart Logic is a consulting company that helps our clients accelerate the pace of their product development. We build custom software applications for our clients, typically using Phoenix and Elixir, Rails, React, and Flutter for mobile app development. We're always happy to get acquainted, even if there isn't an immediate need or opportunity. And, of course, referrals are always greatly appreciated. Please email contact@smartlogic.io to chat. Thanks, and have a great day.